Here I'm going to make one presentation on the solid state magnetism as a part of the assignment on the topic magnetocaloric effect of cobalt oxide. And to introduce myself, I am Sonam Doji, having of registered number 20 M.Sc 0048 under the guidance and tutor of Dr. Sinther Panti R. To define what is meant by definition of magnetocaloric effect. The magnetocaloric effect is defined as heating or cooling of a magnetic material due to application of magnetic field. This effect has been cancelled by demagnetization for years. Through this phenomena is one practical application of MCE in magnetic materials. The magnetocaloric effect (MCE) is a magnetothermodynamic process of coupling between the magnetic moments of magnetic materials and the external magnetic field, which will change the magnetic entropy or temperature concerning the changing of external magnetic field. Now to go with the cobaltite oxides, it has been shown that the phase transitions of rare earth cobaltite are extremely sensitive to small variation in A site. Like manganese iron, cobalt oxides exhibit several possible oxidation states like CO2+, CO3+, and CO4+, and different type of coordinations. As a result, cobaltite present a large field for the creation of many frameworks, not only stoichiometric oxide but also non-stoichiometric oxides involving a mixed valence of cobalt and or presence of oxygen vacancies. The property that distinguishes the cobalt oxide from manganese oxide deals with the ability of cobalt to be present in various spin states, that is, a high spin, intermediate spin, and low spin. Experimental observations indicate that the replacement of La3+ and Sr2+ in this system introduces more holes to the valence band and thus changes the valence of CO from CO3+ to CO4+. This probable spin state makes the physics of cobaltite materials so complicated that it has not been completely understood so far. Spin state transitions can therefore be easily provoked by varying the temperature and the pressure and applying a magnetic field by turning the structure parameter, oxygen content, and nature of dopants of material. These materials are categorized with unusual magnetic or electrical properties such as large negative magnetic resistance. Cobalt oxide of Ln1 XMXCO3, where Ln represents lanthanides, M stands for alkaline earth materials, have attracted much interest because of the existence of spin state transitions and the unusual magnetic properties they exhibit. A phenomenological model for simulation of magnetization dependence on temperature variation was used to predict magnetocaloric properties such as magnetic entropy change, heat capacity change, temperature change, and relative cooling power. The magneto-entropy change (DSM) peak scanning over a broad range of temperature leads to a remarkably wide working temperature region, yielding a significant performance in terms of refrigerant efficiency. The DSM distribution is very uniform for compound, which is desirable for Ericsson cycle magnetic refrigerator. It is a refrigeration technology based on the magnetocaloric effect, an alternative technology to classical refrigeration. So here we have a graph between temperature versus change in entropy, And this graph indicates that the magnetic entropy change as a function of temperature changes as a function of temperature for different applied magnetic field shifts, where sample that has been taken here is EUO 5SRO 5COO3. And it also indicates that the temperature range between 20 and 300 Kelvin can be covered using the EUO5 SRO5COO3 system, where SM peaks span over a wide temperature region, which can significantly improve the global efficiency of the magnetic refrigeration. And then another graph that we have here is a graph between temperature versus again change in entropy. Here this graph shows that magnetic entropy change as a function of temperature at several magnetic applied fields around the Curie temperature Tc for the graph A, LaO6 SRO4CO3, and graph B, LaO4T5 BiO 15 SRO4CO3 samples. Cobaltite with the chemical formula of R1 XaXCOO3, where R represents the rare earth and A represents the divalent alkaline elements, are still of intensive interest because they exhibit a very rich and complex magnetite phase due to the occurrence of thermally compositional and pressure-induced spin state changes. Then we also have a graph here between temperature and the change in entropy. This graph indicates that the magnetic field dependence of magnetic entropy change for LaO6SRO4COO3. And this shows that change in entropy for different magnetic field changes up to 5T for the sample LaO6SRO4COO3. It is interesting to note that the maximum of the magnetic entropy change is obtained around Tc is equal to 230 Kelvin, which is a property of simple ferromagnets due to the efficient ordering of magnetic moment induced by the magnetic field at the ordering temperature. The maximum value of change in entropy are found to be at 1.01 and 2.01 joule per kilogram per Kelvin for the field change of 0 to 2T and 0 to 5T respectively. It is found that the delta S, the change in entropy value of for the sample LaO6SRO4COO3 are comparable to or large than those of some magnetic cobaltite materials with a similar transition temperature. The universal behavior of the magnetocaloric effect in this system was confirmed by the experimental magnetic entropy changes measured for various fields that collapses onto a master curve. It was found that change in entropy values of this material were comparable to other ferromagnetic cobaltites such as La2, 3SR1, 3COO3, and the RCP value of about 106 to 60.64 joule per kilogram is comparable with those determined for some provokite cobaltite and several magnetite systems, revealing the applicability of LaO 45 BiO 15 SRO 4COO3 in solid state refrigeration. Magnetocaloric effect is observed with peaks in temperature dependent magnetic entropy change curve appearing at Curie temperature Tc. However, the peak undergoes a shift to higher temperature for higher field change due to possible augmented short range interactions among ferromagnetic clusters taking place above Tc Curie temperature that effectively modifies Tc to a larger value. And that's the end of my presentation. Thank you.